Video lecture 3.6, mid-latitude low-pressure cells. Now we're in the mid-latitudes where Indiana is, where we have once again convergence. And so we can see that in both of these white boxes, the purple arrows are converging, going head-on collision with the blue arrows. The mid-latitude low-pressure cells are also known as the subpolar low-pressure cell zone area. This is also the polar front, which I'll further describe in a following image. Characteristic we'll find here, stormy weather. That makes sense. Low pressure. Go back when we look at the keynotes, the key characteristics of low pressure, and take a look at them. One of the things we also find that's unique to this low pressure compared to that equatorial low pressure trough there along the equators, here we have cold meaning warm. So that's what I'm trying to describe when I say a steep temperature gradient in this poor mixing zone. Here you have cold meaning warm, which is one of the things we're going to be looking in video lecture 4 a little bit more at. This is a dynamic low pressure, a lot like the subtropical high pressure in the sense that it's not created from temperature differences. It's more physics, mechanical stuff at work, which once again it's not going to be something I'm going to spend too much time on. And here we have once again cold meeting warm. So why is the cold air going underneath, the blue arrow, why is it going underneath the red arrow? That makes sense because cold air is denser, it's heavier. And so that cold dense air is going to force that warm moist air to rise. And so we have arrows colliding, but we have cold air that's going to force the warm air to rise. Key point when we try to understand mid-latitude low-pressure cells, which once again is a focal point of video lecture 4. So now we've zoomed out to the entire Earth scale with the North Pole and South Pole now shown out. So essentially this is the Hadley cell that we've seen before that we've now zoomed out from the side view, the cross-section view. And so here where we are in Indiana, we're roughly in this mid-latitude area, and here we've got once again a low pressure forming as warm and cold air meet and converge with each other. And of course, the southern hemisphere, they've got the same thing going on too.